Hey guys, we are back today with section 6.2, which has to do with polynomial operations. Now, most of this, again, will be review. We're going to get to some new stuff next section. But what this is going to consist of is kind of two things. One, some vocab that we need to know. We're going to be using it in future sections, so we got to be really familiar with it. And then two, just three operations on polynomials. Addition, subtraction, multiplication, which we should be pretty familiar with, especially after going over 6.1. So to start off with our vocab, what is the degree of a variable? Well, I'm going to give you two examples, and then I think you'll know what it is. X squared, the degree of that x term is 2. X to the 7th, the degree of that x term is 7. So what is the degree of a variable? Well, if we're just looking at this one variable expression, x squared, and the degree is 2, that means it's the power, right? It's the power of that variable. What would the degree of x to the 97th be? Well, the degree would be 97. One more. What's the degree of x? Degree is 1, right? It's that invisible 1, x to the first power, so degree is 1. Okay. That's our degree. What if, though, we have more than one variable going on here? What is the degree of a monomial? We've talked about polynomials, multiple terms, binomials, 2 terms, trinomials, 3 terms, but a monomial, mono means 1. So what is the degree of this one term? It's not really as intuitive as you might think. Here's how we get it. We are going to add up the degrees of every individual variable. So this first one, 3xy squared z, that degree is going to be 4 because we have x to the first, y to the second, z to the first. Those ones are invisible, but they still count. Degree is 4 there. Now notice I said we were going to add up the degrees of each variable. One important thing to know is that number exponents don't count. On the second one, you see 2 squared, 3 squared, x, y to the 4th, z to the 11th. We don't count these numbers because, I mean, we could have just written that as 4 times 9, or we could have just written it as 36. So we don't have to worry about those powers, and that's an easy thing to kind of miss out on and get tricked on. We just add up all the powers of the variables. So degree on this one should be 16, 11 plus 4 plus the invisible 1 for the x. Degree is 16. So degree of a variable, just its power. Degree of a monomial, add up all the individual degrees of variables. Now we're going to change things again. Another degree. Last one. What is the degree of a polynomial with multiple terms? Well, here's how we do this. We look at each term and we find their degrees and we say, okay, so this degree is 2, this degree is 1 because it's x to the first, this degree is 0, there aren't even any x's. And once we've done that, we take the highest individual degree. This one's weird because we don't add them up necessarily. We take the highest individual degree, and that's the degree of the polynomial overall. Let's do that again down here. So the degree of this term is 4 because 1 plus 2 plus 1. The degree of this term is 7. The degree of this term is 5 because of that invisible 1. So the degree of this second polynomial overall is 7. Okay, so these are just things we're going to be talking about degrees and going to be mentioning that a lot this chapter. We need to know how to calculate degrees. If it's just a single variable, it's easy. It's its power. If it's one term, no pluses and minuses, just one term, things being multiplied together, add up all the degrees of the individual variables. And if it's a polynomial, if it's multiple terms, you're going to find the individual degrees of each term, take the highest one. Okay, little bit more vocab for you. Descending order. All that means, descending means kind of going down, right? So descending order means we want to write our polynomials in the way that we are used to seeing them, meaning the powers go down. We have x cubed, then x squared, then x to the firsts. then no x's at all. That is in descending order. The second one is also in descending order. X to the fourth, x cubed. I know we're missing x squareds and x's. We have 0 of each of those. And then we go to no x's at all. So we're missing some, but it is descending, right? It is always going down. And so that one is in descending order. The third one isn't quite. Let's put the third one in descending order. So x plus x cubed minus 1 minus 2x squared. I'm hoping that makes kind of your skin crawl as much as it does mine. In descending order, we would need that positive x cubed first. So we've taken care of that. Minus 2x squareds next. Taken care of those. Plus x minus 1. And so we just rewrite it, making sure we keep the signs the same. And now if we look at it descending order, sure thing, x cubes, x squareds, x's, and just 1. All right, last bit of vocab is just what is the leading coefficient? The leading coefficient is the coefficient of the leading term, the first term we see in the polynomial, when the polynomial is written in descending order, and that's important. It's the coefficient, the number in front of the highest degreed term. So when it's written in descending order, what would this be? This would be, we need the negative 3x to the fourth first, then the plus 2x's, so putting it in descending order, plus 1. And so what is my leading coefficient? Negative 3 in this case. It's that number in front of the highest term. That's what the coefficient is. Leading just means it's in front when it's in descending order. So I kind of just whizzed through that, but it's vocab, it's definitions. I mean, if you need to pause and write something down, absolutely do it. Write a couple examples down, make sure you understand this. But the good news is it's not really like new processes or anything. So let's talk about polynomials then. How do we add and subtract polynomials like we have been doing for years now? We're just going to combine like terms. And this is just, again, this section, it's not meant to patronize. It's just making it formal. So now we've talked about it and we can all agree on it and no one's assuming that you know anything. 3x squared minus 6 plus negative x plus 1. Well, I'm going to write this in descending order. That's how I always should. So I'm going to do the x squareds first. 3x squared, and that's the only x squared. So it's just 3x squared. I'm going to do the x's next. So plus a negative x is all I see, so minus x. And then I'm going to do the constant. So negative 6 plus positive 1 looks like minus 5 to me. Adding polynomials, not much to it. What about subtracting? Same, we just have to be really careful that we distribute that minus. And so what I'm talking about is negative x squared minus x squared, that's going to be negative 2x squareds. Negative 3x's minus positive 2x's, that's going to be negative 5x's. And we just got to make sure that we always use that minus. Minus 5x's. Plus 4 minus a positive 5. So 4 minus positive 5 minus 1. And we just want to make sure we're using that minus every time because we are subtracting that entire second term, second polynomial. So negative 2x squared minus 5x minus 1. But what is it really? Just combining like terms. What about multiplying polynomials? Multiplying polynomials, kind of after we went through 6.1 in the last lesson, they should come really easily. The first one, negative 2ab squared times negative 3a squared minus 11ab plus 20. I'm just going to distribute and use my exponent rules. So negative 2 times negative 3 is positive 6. A times a squared is a cubed. We add those exponents, remember, just like in 6.1. B squared, and then there are no more b's to multiply by, so it's just b squared. Plus 22 a squared b cubed, it looks like, minus 40 ab squared. And so if we are multiplying polynomials out and it's set up like this, we can just distribute in and use those exponent rules. Really similarly, what if it's set up right here? We're going to have to FOIL, except it's not a 2x2, so it's not really foiling. We've seen this before. We're just going to keep drawing arcs and make sure we hit everything in the first polynomial with everything in the second polynomial, and make sure that we don't leave anything out, combine like terms at the end. Now, I'm going to show you, and this is kind of a unique thing. This is something I saw one person. I haven't seen many people do this. I kind of liked it. Maybe it'll help. So I'm going to show you. X squared times 5x, 5x cubed. X squared times negative 3x squared would be minus 3x to the fourth, using those exponent rules. 2x times 5x, 10x squared, plus 10x squared. And then here's kind of that unique thing I was talking about. The next one, 2x times negative 3x squared, negative 6x cubed. I'm going to write that right here. And I kind of like this. I like just lining up my x cubes. It'll make it really easy to simplify in the end. Line up all those like terms. So negative 3 times 5x minus 15x's. Negative 3 times negative 3x squared is positive 9x squareds. And again, I'm just lining those up with the x squareds. So that now I can just combine those like terms. It's super easy. Again, we had 6 little arcs. We multiplied 6 times, which makes sense because it was a 3x2. So it's negative x cubed minus 3x to the fourth plus 19x squareds minus 15x. Again, just really easy to simplify. Just combine them straight down. Last thing I do, I'm going to put this in descending order because we always should. So negative 3x to the fourths minus x cubes plus 19x squareds minus 15x's. And that would be our answer when multiplying those polynomials. So guys, that's it for this section. This section is that vocab, degree, leading coefficient, descending order. Make sure you kind of have that somewhere in your notes, you have that down. And then adding, subtracting, multiplying polynomials, which is pretty familiar, and maybe just some exponent rules thrown in. Otherwise, we've done that before. So what is missing? Dividing polynomials. And we're going to see 2 different techniques for that, and we're going to see that covered in 6.3. So if you're wondering why we weren't doing dividing, it's not that I'm just shielding you from it. It's coming in the next section, and so be ready for that. But make sure you're working on the practice problems. Make sure you have these down, and that if you have questions, you write them down so you can ask me next time we're together. Otherwise, that's it for this video, and I will see you again in 6.3.